Welcome to the next video in the systems programming video series, and we are picking up where we left off in assignment 8, where we are basically implementing our own implementation of malloc. So to get started, when this function is called, of course, we are given some kind of a size input, and we are meant to update the memory space where this data could go into heap memory. So we ought to basically say, update the thing that is tracking the chunks of memory, which is this global variable called flist here, initially null, and acting like a linked list pointer. So we should update that. And we should also return the pointer. And keep in mind, look at the return value here. This is a void star, so it's returning a pointer. And that pointer that it returns should be the address at which you start putting the data. And so, as I think we've talked about briefly, and we didn't see the details, now we're going to see the details, but I think I've mentioned before that when you malloc something, not only do you get an address to some portion of heap memory that has now been reserved for this data, but also a little bit of header data is written into memory near there. And in fact, that's exactly what this is. This is the header data, or at least for our implementation, that is going to be the header data that is written to heap memory. So to get started on this, let's say that we're going to have this pointer to a struct hunk, so struct or chunk, and I'm going to call it new hunk, right? So this is going to be the hunk of memory that it, or really the header data in some sense, right? The pointer to the header data, where close to where we're going to be putting this allocated memory. And so exactly how that gets determined we'll figure out in a minute, because it's going to somewhat depend on whether or not we have to request new space or not, and so on. So now, before doing too much, we should handle a fairly trivial situation where the user inputs a size that is 0. And if the user inputs a size 0, then you really shouldn't have any memory for anything. And so this is a bit of a sort of trivial case. But let's say that if the size is 0, then we should return null. So just a trivial little check on an edge case. But otherwise, we would like to know whether or not the linked list of heap memory already exists. If it does not already exist, then we need to create it. That's kind of what happens at the very beginning when this thing is null and we have yet to allocate or request any amount of space from the operating system. So if the flist does not yet exist, then we need to make it exist. And in particular, we're going to want to request space from the operating system. So since, as I've mentioned in the previous video, that kind of makes sense to abstract into its own function, then we should do that now. So we're going to, right, that is going to populate the new hunk, because that's going to be like the address where the header is saved. But it's going to get done by this function request that we're going to create called request space. And the request space function should take two things, right? It should take the address of the last chunk of memory, right? Because we're requesting space, so in some sense we'd like to work our way to the end of the current existing memory. And then also a parameter for the size, saying how much extra space beyond what already exists are we requesting. So it should take those two arguments. Now, in our particular case, there is no pointer, right? So we're going to say that the pointer to the last thing in heap memory is actually null because it doesn't exist yet. And the size that we are going to request is going to be exactly the amount of size that was requested by the user. So we are going to request precisely size. Now keep in mind that when we pass this request for size in, that is going to request the size of the space that is needed to fill the data, to accommodate the data from the user's perspective, right? The user is going to say, I need 2 bytes, whatever, thinking only from their perspective as needing some space in memory. When we implement this function, are going to need to say, yes, the user wants this amount of memory, but we implementing malloc understand that not only does it need that, but it also needs a little bit of extra space for the header. So that's going to be our job to handle that. We are going to request from the operating system a little bit more than size, but we'll do that inside of request space. Let's go ahead and start implementing request space so that we get a good sense of exactly what it's doing before we continue using it. So let's go ahead and make this function, and it's going to return a struct chunk pointer. It'll have a struct chunk pointer last, right? That is the pointer to the last place in heap memory where so far some memory has been allocated, or the header of the last allocated chunk of memory. And then we're going to have size t size. So this is the information that request space needs to have. Now, the first thing that we want to do is we want to know where the current top of the memory heap is. And so for that, we're going to call struct chunk star top hunk, we could call it, is equal to sbrk of 0. So so I am requesting 0 amounts of extra memory. And that's because right now I don't actually want to yet make the memory request. I am only, because the return value of this function, what does this function do? Not only does it request a certain amount of extra memory, although in my current use, that's actually no memory, but what I'm actually using it for is the second thing that it does, which is to return the pointer to the top or the furthest out location of available heap memory. So the next thing that I want to do is to actually request additional memory from the operating system. And so for that, I'm going to say void star, right? So I'm going to get a pointer to a new location in memory, rec, that's the requested memory, equals sbrk. And now let's say how much extra space we want. Well, we know that the user's requested size is at least some amount of what we want to request, but also, so on top of that, we want to request the size of the header. And so the size of the header is struct chunk. So now what is this return value? This return value is the old top of the available heap memory. And so if you think about it, well, they should match, right? What used to be the top of the heap memory should be the same as the old top of the heap memory now that it has incremented by a certain amount. And so these two should match. And in fact, that's the entire point of doing both of these things, is to just make sure that everything went correctly. So let's do a check, right? We say if. Now, to compare these, I do want to make sure that they are of the same type so that the comparison comes out correct. So I am going to cast my top hunk. In fact, maybe I should have, in fact, yeah, why would I make this struct chunk when in fact I could just call it void star, and then I could just compare top hunk, whether it is equal to rec. So if they are not equal, and also there's a certain code that returns if anything goes wrong. So I want to say or rec is equal to -1, right? So that's the code for something went wrong as the return from this sbrk. By the way, I guess I should also mention sbrk, that's a system call, right? So that means that I am requesting from the operating system. So if you remember some of what we talked about from the textbook, this is an instance of a system call. And so if any of that is true, that then something went wrong, and I'll just print that something went wrong. Oh, but what if nothing went wrong, right? So what if it was successful? Well, as of now, we have not yet updated the F list or anything like that. And so let's think about how, oh, but at this point I would want top hunk. Maybe that's why I previously declared top hunk as a struct chunk star rather than a void star. But let me go ahead and do that now. Let's say that top hunk should now be cast to struct hunk chunk star. And now I want to say that if the last thing exists, right, because we already know that sometimes we're going to pass this null, namely when there is no heap memory, and sometimes we're going to pass it an actual pointer to the last bit of heap memory. So if last already exists, then in fact I want to make sure that last gets updated. So I'll say last next is equal to top hunk, right? So this new hunk that we have created, and by the way, at this point, both top hunk and rec, they point to the same thing. So they're basically pointing to the address right before the newly created data or allocated space for heap memory. So they point to the same thing. So we could say top hunk here, or we could say rec, it shouldn't matter. So now that that has been done, we next want to actually give top hunk, the struct that is at location top hunk, we would like to give it all of the data that it needs to have. So we'll say top hunk holds a size parameter, and we're going to give it the passed in size. And so, okay, maybe that was a mistake. I should go back. Yeah, I don't know that we can cast things like I'm trying to do here. So let's say struct chunk star. Now here I would cast it to void star temporarily, and I think that's fine. Then here I don't need this line anymore, and now that works. Top hunk next. So what does the top hunk point to? Nothing, because it is only the latest thing anyway. And then top hunk free. Well, if it has just been created, it was created for a reason, so it is not free. And then we return this top hunk. And so there is my request space function. So again, just to summarize, I just sort of collect data to know where the top of the current heap memory is. I then truly request extra space, but the request returns to me the old top of the heap. I would like to make sure that they were equal and that the request did not signal any failure. If it did, then I'll just do this, but if it didn't, then I would like to update the last pointer. But whether the last pointer gets updated or not, I am ultimately returning this newly formed struct chunk. And so that's what gets returned. And I guess keep in mind, well, but it's not the struct itself, but the pointer to the struct. So that's what gets returned. And so when I call request space here with null size, then this new hunk is the address of the top pointer. And so, although at this point we know that it only happened because we passed in null, and so this has just created what should become the F list. Now, before doing that, though, let's just make sure that everything went fine. So let's just say that if new hunk is null, basically, is what that is asking, then return null, right? That if the request failed somehow, I think it would have been caught already by the checkup above, but just why not? Let's just check here. And then finally, flist gets updated. So now finally, flist exists. It is new hunk. And so that's what should essentially happen at the very first call to malloc. And so now we want to start thinking about what happens after, right? If we make successive calls to malloc after that. But maybe let's save that for the next video.